Hello, my name is RD, and in this problem here, we are asked to find out I0 using mesh analysis. Okay, so how to do that? The first one will be to label all the mesh or the loops. Okay, here we have 3 loops here. 1, 2, 3. Let's draw it so you can see it clearly. So here we will have this one here as loop I1. Good. And then here we have the second loop, which is I2. Good. And then here we have our third loop, which is I3. Right? So we have I1 here, I2, and I3. I assume all of them are clockwise, but you can also assume all of them are clockwise, as long as you are consistent with your loops when solving the problems. And then the second one will be do KVL for all loops. Do KVL for all loops. Okay, we have 3 loops, so we have to do 3 KVL, and it will resulting in 3 equation. Okay, let's exactly do that. So the first one will be KVL at loop I1. Let's write that KVL at loop I1. Okay, KVL said that the sum of the voltage in a loop will equal to 0. This is KVL. And we have to be very careful about the sign of KVL. Okay, here, let's start with this 10-volt voltage source. And the current here is flowing from the negative terminal. So it's flowing from here, right? Because it comes from here and it goes here. So it goes from negative to positive, and that will make our sign is negative. So we'll have negative, and then the value will be 10 volt. So we already have voltage, so we have minus 10 here. Okay, now let's move on to this 1 kilo ohm resistor here. Okay, but we have a resistance here. So we will have 1 kilo ohm. But we need voltage. But remember Ohm's law, to get voltage from resistance, we need to multiply it by the current. But here, currently, we are working on I1 here. So we multiply it by I1. However, in this 1 kilo ohm resistor, there are also another current, which is I2 here. I2 is flowing to the opposite direction of I1. I2 is flowing there. I1 is flowing there, right? So I will have to subtract it with I2. So I will have minus I2. Good. And then what else? We have one more component here, which is this 10 kilo ohm. So I'll have 10 kilo ohm. And again, because we are currently working on I1, we multiply it by I1 first. And then here I3 is flowing to the opposite direction. So I will have minus I3. Okay, and I think we have done all for I1. So all of that will equal to 0. Okay, maybe let's do some mathematics here. So we'll have minus 10. And here 1 multiplied by this is just I1 minus I2. And let's distribute this 10. So we will have 10 I1 and then minus 10 I3. All of that will equal to 0. Okay. I1 plus 10, that will be 11 I1. Right? So we'll have 11 I1. And then I only have I2 from here. So I'll have minus I2. And then minus 10 I3. Minus 10 I3. And let's move this minus 10 to the right hand side. So I will have this will equal to 10. Okay, I think nothing that we can do further from here. Let's save this as equation number 1. Okay, now let's move on to loop number 2, which is KVL at loop I2. Let's do that. So we will have KVL at loop I2. Again, KVL said that the sum of the voltage in a loop will equal to 0. Good. Let's start from this 1 kilo ohm resistor. But we need voltage, so we multiply it by current. But here we are currently working on I2, right? So we will have to multiply it by I2 first. However, here I1 is flowing to the opposite direction. I2 is flowing there, I1 is flowing there. So I need to subtract I1 from this. So I'll have minus I1 here. Good, and we are done for this 1 kilo ohm resistor. Now let's move on to this 3 kilo ohm resistor. So we'll have 3. Again, because we are working on I2, we multiply it by I2. And that is the only current that passed through this 3 kilo ohm. So I'll have I2. And then what else? We have another 3 kilo ohm resistor, but is this one, not that one. So we'll have 3. Again, because we are working on I2, we multiply it by I2 first. But here, I2 is flowing to the left, but I3 is flowing to the right. So we need to subtract it by I3. So I'll have minus I3. Good, all of that is equal to 0. Okay, now let's do some mathematics. I2 minus I1, and then plus 3I2. Let's distribute this 3, so we'll have 3I2 minus 3I3. All of that will equal to 0, and then we'll have minus I1, and then plus 1 plus 3 plus 3, that will be 7, I think. Yeah, 7I2. 7I2, and then I3 only comes from here, so we'll have minus 3I3. Good, all of that will equal to 0. Let's have this as equation number 2. Good. And now let's do another KVL, but this time in the last loop here, which is I3. Let's do that. KVL at loop I3. KVL said that the sum of the voltage in a loop will equal to 0. Okay, now let's do this 10 kilo ohm. So we'll have 10 kilo ohm. And now we are working on I3, so multiplied by I3. But here I1 flowing to the opposite direction, so I will have minus I1. Good. And then what else? Plus, we will have this 3 kilo ohm. But now we are working on I3, so I3 came first. So we'll have I3, then minus I2. Okay, and then this 2 kilo ohm, so I will have plus 2 kilo ohm, right? And the only current that passed through it is I3, so I will have I3. And all of that will equal to 0. Now, because we are run out of space, I just do this. 10 multiplied by minus 1 is minus 10, so I'll have minus 10 I1. And I1 only comes from this part here. And then I2 only comes from this part here, so I will have 3 multiplied by minus I2. We'll have minus 3 I2. And then for I3, I will have 10 plus 3 plus 2. We will have 15 I3. 15 I3. And all of that will equal to 0. And here we will have our third equation. And now we have 3 equations. 1, 2, and 3. And we also have 3 variables. We have 3 equations, 3 variables. We should be able to solve it by using system of linear equation. So the third step will be solve it using linear system equation. But this will be slow if you do it manually by elimination or substitution. So I will use calculator in this step. Calculator. Right? So how to do that? Let's get out of our calculator here. So here's my calculator, my Casio calculator. Let's set this up here as equation solver, which is number 5. And we have 3 variables here. So we take number 2 here. So we have number 2. And then we plug the coefficient of each equation. So this is equation number 1. So we'll have 11. And then minus 1. And then minus 10. And then the constant term here is 10. So I will have 10 here. Okay, now let's move on to the second equation. We will have minus 1 as the coefficient of I1. And then 7 as the coefficient of I2. And then minus 3 as the coefficient of I3. And then 0 as the linear term. Okay, so this one here, we will have minus 10 as the coefficient of I1, and then minus 3 as the coefficient of I2, and then 15 as the coefficient of I3. And then the linear term will be 0, and we will get the x value, which is the value of I1. So that is the value of I1. Okay, let's save that. I1 is, what is it, 3.41 something, I think, 41.6, yeah. And the unit will be in milliampere because this is volt and this is kilo ohm, so we will have this in milliampere. And what is I2? I2 is the y value, so we will have this one, and we'll have 1.601, 1.601, and the unit will be in milliampere. And then the third value here is the Z value, which is 2.598, 2.598, and the unit here is in milliampere. Okay, and that is the third step. And then the final step should be answering the question, right? Answer the question. And what does the question asking us about? It is asking us about I0. Okay, I0. What is I0? I0 here is I3 because that is the one that got the same direction. So the positive side is I3. And then the negative one will be I2 because it goes to different directions. So I'll have minus I2. And what is I3? I3 is that one, 3.416. And then, no, I3 is not this one. I3 is 2.5. So I'll have 2.598. And then minus I2, we will have 1.601. And so we will have the final value of I0, and that will equal to, okay, let's set this up. So we'll have 2.598 and then minus 1.601. Good. Oh, it's not 11. Yeah, that. So we'll have 0.997, 0.997 milliampere, and maybe just approximate it into 1 milliampere. And I think that's all for this problem. Here is the final answer for this problem. Thank you for watching. See you in the next video. Bye bye.